This is January 2015, paper 2 and question number 1. So we've got electrical energy and it's transmitted using a high voltage of 132 kilovolts, right? So a voltage of 132 kilovolts is the same as, it's not the same as 132 because you've got that modifier of kilo there. It's not the same as 1320. It's not the same as 132 million, it is the same as 132,000. Remember that kilo, it means times it by 1,000. And then you've got all these other prefixes that you can use. You've got milli, which means divide it by 1,000. So you would have seen like 10 millimeters. So you're going to divide it by 1,000 in order to get it into meters. And then you've got 10 kilograms, which means times it by 1,000 in order to get it into grams. That just means times by 1,000. There's a few ones you need to know. I would say you have to know milli and kilo and maybe mega as well, which means times by 1 million. There are a few others, they're very good for physics to learn them. Using a high voltage increases is it the current in the wires? Well, we know as the voltage goes up that the current must go down, so it's not the current in the wires. That comes from the equation P equals I times V. We can't create more power by upping the voltage, so if the voltage goes up, the current has to go down. Is it the energy lost as heat? Well, it can't be the energy lost as heat because that's working at a very high voltage. It's not the resistance of the wires, that doesn't make any sense. It's only the efficiency of the transmission. That's a lot more than we can get into in this one question. I'd go and have a look at the Firefly pages looking at why we use high voltages. The high voltage can be reduced using well, this is paper 2, so we know it's all our paper 2 stuff, just for our specialist program, and that was the transformer. Using transformers to step up or step down voltage. And that's question number 1.